Hello everyone. In continuation to our topic analytical geometry, this is question 3. Find the distance between the following pair of points. Point A is A cos alpha and A sin alpha, and point B is A cos beta, A sin beta. So we need to find out what is AB. AB will be square root of A cos alpha minus A cos beta the whole square plus y coordinate is A sin alpha minus A sin beta the whole square. That means AB is equal to, let us expand as A minus B the whole square. So it is A square cos square alpha plus A square cos square beta minus 2A square cos alpha cos beta plus expanding A sin alpha minus A sin beta, we get A square sin square alpha plus A square sin square beta minus 2A square sin alpha sin beta. All this entire thing under square root. Okay. This is equal to, we may notice everywhere A square is common, we can take that outside the square root, it will become A. So A, then first we have this cos square alpha plus sin square alpha. Let me mark it. Cos square alpha plus sin square alpha. That becomes 1. Sin square alpha plus cos square alpha is 1. Again, we may notice cos square beta plus sin square beta is there. So again, one more 1 to be added. Then we have minus 2 times cos, or we can take that minus outside in both of them. In this also, in this also, we'll take minus 2 outside. So we will have cos alpha, cos alpha, cos beta plus sin alpha, sin beta. That means we have taken everything into consideration. So now we may notice this is nothing but a root of 2 minus 2 times. Now we have cos alpha, cos beta plus sin alpha, sin beta, which is nothing but 1 minus of cos of alpha minus beta based on trigonometric functions. Let me put a square root for this. And let me write, since cos A cos B plus sin A sin B is equal to 1 minus of cos of A minus B. So based on that, we wrote this. Now we will take 2 outside the square root, or we can retain 2 only inside the square root. 2 times we can write 1 minus 1 plus cos alpha minus beta. So this and this gets cancelled. We have 2 times cos alpha minus beta. Cos of A minus B is nothing but sine square A minus B by 2. So on that basis, we will rewrite this as A square root of 2 cos alpha minus beta will be sine square alpha minus beta by 2. Sorry, this will be 2 times, not this will be 2 times. So we will write this as 2 times. Okay. Now there are 2 2's inside the square root, so we can take it outside. It will become 2a root of sine square alpha minus beta by 2. Now we can apply square root. It will become 2a times modulus of sine of alpha minus beta by 2. Because it is distance, even negative value needs to be considered as positive value. So that is the solution for this particular question. Next is question 4. Find out the relation that exists between x and y so that x comma y is equidistant from 6 comma minus 1 and 2 comma minus 3. So let us say, let point P be your x comma y, then point A be 6 comma minus 1, and then point B be 2 comma 3. Given xy is equidistant from this point and this point, that means given PA is equal to PB, which means PA the square is equal to PB the square. Now PA the square is x minus 6 the square distance formula plus y minus or minus 1 y plus 1 the square. Now PB the square is x minus 2 the square plus y minus 3 the square. Now let us expand this. Left hand side it is x square plus 36 minus 12x plus y square plus 1 plus 2y. Right hand side x square plus 4 minus 4x plus y square plus 9 minus 6y. Both sides we can cancel x square. Both sides y square also can be cancelled. So this is 36 plus 1, it becomes 37 in the left hand side, minus 12x plus 2y should be equal to 4 plus 9 is 13 minus 4x minus 6y. So let us take this negative 12x to that side and bring this 13 this side. So 37 minus 13 is equal to 12x minus 2y minus 4x minus 6y. So that will give us 24 is equal to 12x minus 4x is 8x. This is minus 8y, which means let us divide both sides by 8. We get 3 is equal to x minus y. That is the relationship between x and y.